Let's see another quant question from SIG. Two points are uniformly distributed around the circumference of a unit circle. What's the expected value of the distance between them? So we have a unit circle like this, radius 1, and we are told that 2 points are picked somewhere on this circle, the circumference, uniformly. And we are asked that what's the expected value of the distance between them? So this distance, what's the expected value of this distance d? Let's call it d. So let's go ahead and solve this. The first thing to do is how do we represent the points on the circumference? So any point can be represented as r cos theta, the x coordinate, and y coordinate would be r sine theta. Now, since this is a unit circle, r is 1, and we have 2 points, so we assume that the angle for the first point is theta 1, and the angle for the second point is theta 2. Theta is uniformly distributed, so theta I is uniform between 0 and 2 pi. Now we have to find the distance between the points. So the Euclidean formula, for instance, is x1 minus x2 whole squared plus y1 minus y2 whole squared under root. This gives us the distance between the points. We have the x coordinate cos theta 1 and cos theta 2. So cos theta 1 minus cos theta 2 whole squared, and then sine theta 1 minus sine theta 2 whole squared. This gives us d. To get rid of the square root here, we square on both sides and then expand it using a minus b whole squared gives a squared minus 2ab plus b squared. Same thing here, a squared minus 2ab plus b squared. Collecting the terms cos square theta and sine square theta on one side, these two will sum up to 1, and then we are left with minus 2 cos theta 1 cos theta 2 plus sine theta 1 minus sine theta 2. So we have 1 plus 1 minus 2 times this part, which this is equal to, from trigonometric identities, we can identify that this is equal to cos theta 1 minus cos theta 2. So we write this part as cos theta 1 minus cos theta 2. So the expression for d squared becomes d squared equals to 2 times, we take 2 common, we are left with 1 minus cos theta 1 minus theta 2, which means that d is equal to under root 2 times 1 minus cos theta 1 minus theta 2. Now, because we have to find the expected value of d, we know that expected value of, let's say, a function gx would be integral gx times f of x, the distribution pdf is probability distribution function, times dx, and integrated from minus infinity to infinity. So in this case, this function g would be this function which we have here, f of x. This would be 1 over 2 pi, because this is a uniform distribution between 0 and 2 pi. But the thing is, before we do this, we need to be clear on what exactly are we integrating against. So here we have two variables, theta 1 minus theta 2. What we'll do is we substitute this theta 1 minus theta 2 with delta, the difference between the angles. And since theta is uniformly distributed between 0 and 2 pi, we can say that delta is also uniform between 0 and 2 pi. So the problem reduces now to finding expected value of d, written as e of d. This part, 1 over 2 pi, is constant, and this comes out of the integral. We are left with 2 times 1 minus cos delta under root times d delta, and integrated from 0 to 2 pi. Now, once again, from trigonometric identities, we can write 1 minus cos delta as this part as 2 sine squared delta by 2. So the term under square root becomes 2 times sine squared delta by 2. This is 2 times sine delta by 2, the absolute value of sine delta by 2. So now we have to compute this integral. Expected value of d equals 1 over 2 pi, 0 to 2 pi, 2 times sine delta by 2. The 2 is constant, it comes out of the integral, cancels, we are left with 1 over 2 pi. Now we substitute delta by 2 with u, delta by 2 with u, in this integral. So d delta becomes 2 du. The 2, we substitute this, and this gives us sine u times du, and the 2 comes out of the integral as it's a constant. The integral of sine u. Okay, so first the absolute value. So the because in 0 to 2 pi sine u is positive, we can get rid of this absolute value of sine u, can just be written as sine u. So this part becomes sine u du, and integral of sine u is minus cos u. We put the limits of the integral from 0 to pi. This gives us minus cos pi plus cos 0, which is 1 plus 1 equals 2. So the final answer, expected value, this 2 and this 2 and the other 2, which we had in here, which we took out of the integral, this one, these are multiplied, so we get 4, and the 1 over 2 1 over pi, which we had from the beginning, gives us 4 over pi as the expected value of the distance between the points. So this is the answer to the question. It's a pretty simple, straightforward question. You just have to know keep a few things in mind: the parameterization of points on the circle, distance between points in Euclidean space, easy formula, expected value over a uniform distribution, and a couple of trigonometric identities. That's all that's needed for you to solve this question.